Hello, class. I'm here to talk about another section that is presented during chapter 9, which is a main concept in hypothesis testing. And I decided to go over before we jump into the problems, because if you are presented with any of that, and you are going to be presented with some of these problems on your final exam. So I want to make sure that this concept is very clear before we move on. If you remember from my previous video, I have addressed how to identify how do you choose your claim, or how do you state um, your claim or your statement. And the way I showed you, which here should be 0, and the way that I told you was to read the problem. Let's do like this. For example, the mean number of years Americans work before retiring is 34. And I said you're working with means, so you would be working with this, the top portion and not the bottom portion, correct? Sorry for formatting now. I did as much as I could before. So the mean number of years American work before retire is 34. So it's the mean is equals to 34. Therefore, if you go and look at all this, the statements that will have the equal sign would be where the null hypothesis is equals to. Therefore, your alternative hypothesis is going to be different then. Okay, so and then also the mean, so you're going to be working with these statements. Okay, I put it here proportion. If you were if you're being presented with a percentage, in this case 60%, but I still use 34. So let's say they will say that at most 6% of Americans vote in presidential elections. At most, no more. So less than 60, but including 60. So less than 60 equals to 60. You would be using this one. So it's a proportion because it's a percentage. So actually would be using this statement right here. And okay, perfect. I will leave the other ones here. Doesn't mean that they all refer to the problems below. It's just to give you an idea. When you have the no hypothesis equals, you have the alternative as different. Then when you have the no hypothesis greater or equal, then you have the alternative hypothesis is less than. And when you have the no hypothesis less or equal then you have the alternative hypothesis is higher than. And I will leave this here, and now we're going to address the type 1 and type 2 error, which this table here I took from your book over here. And it actually, compared to a lot of tables that I see out there, it explain it in a decent way. Well, you're you have your claim, and your no hypothesis, you decide that you know not decided, you tested, you went through the whole through every single step, through the whole process, and you have learned that your no hypothesis is actually true. So we're on only on this side of the table. Okay, I'm not looking at the other side of the table. So you figure out after everything that the no hypothesis is true, then you do not reject the whole null hypothesis, which would be the correct outcome, correct? To reject the null hypothesis based on your numbers, and you would be doing a type 1 error. So when you reject a null hypothesis that is true, that is actually true, you are going to have a type 1 error. And here you see do not reject. You're also going to see the wording fail to reject. So if you hear fail to reject, do not reject, accept, they're all going to be the same thing. And just remember that type 1 would be when you have confirmed the null hypothesis is true, but for whatever reason, because of you miscalculated, or I don't know, I don't even want to address the other options, and you reject, then it would be a type 1 error. On the other side of the coin, we have the type 2 error. Okay, now the null hypothesis that you're testing is actually false. And I'm going to show an example. Okay, and then it's false, but you did not reject the null hypothesis, even though you have confirmed through your calculation is false for whatever reason. Either you miscalculated or maybe it's in your favor. So if you do not reject the null hypothesis, then it's a type 2 error. However, if the null hypothesis is false and you reject it correctly, then it's fine. Okay, so two different things. Don't do it all together. When you look at the tables and the information presented to you, remember this is for type 1 and this is for type 2. Okay, here's one example that I use every term that might even sound funny, but it's really, I thought, to kind of take to the extreme to make see if students can understand better. So in this case, a doctor is telling him he's pregnant when we know it's pretty much impossible or impossible. Therefore, he's confirming false. He's confirming something that is false, a false positive. And here, in this case, since we are basing everything under pregnant, not pregnant, so we are talking about pregnancy here. In this case, she knows the truth is she's pregnant, but she's denying, she's rejecting the fact that she's pregnant. She's rejecting the fact that she's pregnant, or she's accepting the incorrect outcome. Therefore, she's giving a false negative, which is a type 2. Let's go ahead and go over the examples, over the problems, and see if it becomes more clear how to state a type 1 and a type 2. Okay, for example, trying to make it a little smaller here. On problem 66A, the mean number of years American work before retire is 34. Well, here, how would we do a type 1 error? Well, the mean number of years Americans work before retire is 34. Well, the type 1 will be, we conclude that the mean is not 34 years when it really is 34 years. That means we would be rejecting our null hypothesis when it's true. Type 2, we would conclude that the mean is 34 years when in fact it really is not 34 years. Type 2 would be, we know that in this case we would know that we have tested everything and we figured the mean number uh, Americans work before retire is 34. We would conclude this is not true, but we would say it is true. For we will have a type 2. Let's try B. At most 60% of Americans vote in presidential elections. A type 1 error is we confirm that, we conclude, okay, let me go back here. At most 60%, therefore no more than 60%. Type 1 would be, we conclude that more than 60% of Americans vote in presidential elections when the actual percentage is at most 60%. So we said that is type 1B, we said is at most. However, we concluded after we tested there is more than 60%. So we made a type 1 error. Okay, so then let's go to the type 2. In this case, we would conclude that most of 60% of Americans, we conclude that actually, yeah, at most 60% of Americans, no more than 60%, vote in presidential, oops, sorry about that, gee, elections when in fact more than 60% do vote. Type 2 would be we test everything, we concluded that no more than 60%. The alternative, we have confirmed the alternative. However, in fact, more than 60% vote. Let's go to C. What is C? The mean start salary for San Jose University graduates is at least 100,000. So that means at least equals to higher or equals to. So a type 1 would be we conclude that the mean start salary at University of San Jose, right? Isn't it? Uh, San Jose State University. Oh, let's abbreviate here as San Jose State University. Oh no, graduates is less than 100K when it really is at least 100K. A type 2 error would be we conclude, I better just type it. We conclude that the mean starting salary for actually for graduates is at least 100K when um, when in fact it is less than 100K. Type 1. And another way for you to also, let's, in this case, we're saying that the start selling for SJSU graduates is less than 100,000 K. Therefore, your null hypothesis, right, is equals, your null hypothesis is going to be the mean. Just see if that makes it any easier. Is at least, so 100K. Therefore, your alternative hypothesis, let me just copy here to see if it makes any faster. Your alternative hypothesis, it's going to be okay, right here we're saying that no hypothesis is at least 100,000. So we conclude that the mean start salary is less than, so this is incorrect, when it's really at least. And here we conclude that the mean start salary is at least 100 when we are saying is in fact less than. This will be your type 2. Sound very confusing, but the more you go, you look at the examples and you put every single symbol and wording that you need, and then you refer to this table, for example, which right here we could try another one. Okay, so we conclude. So what is the actual when the actual percent is at most? So therefore, my null hypothesis is at most and is a proportion, correct? Because it's a percentage, and at most, so no more than or equals to at most 60%. Therefore, my alternative has to be that the proportion is higher than 60%. Now let's go back and take a look here. Here we're saying we conclude that more than 60%. See how we're here saying less than or equal to? We know the truth is that it's is at most. However, we are saying, however, we are rejecting the truth, right? Rejecting the truth and making a type 1 error and say that we say there is actually more than 60%. On the second one, on the alternative hypothesis, we know that we would have that in fact more than 60% do vote, but then we say that no more than 60% vote. Okay, so in this case, we have accept the null hypothesis when we have confirmed that more than this actually vote. So we made a type 2. Again, little by little, you look at the problems and start. This is not, I don't expect you to understand this right away. I'm just going to do a few more and you can do the rest on your own. The 25%, well, we're dealing with proportion, high school seniors get drunk each month. So let's see if we can first define it here. I believe that will make it easier. So 25% of seniors, so we know that my HO, and we're dealing with the percentage, 25%, therefore equals, yeah, equals to 25, therefore, oh, my alternative is going to be the proportion, percentage is different than 25%. Okay, so how do we make a type 1 error? We know that this statement here is true, but we're going to reject it, okay? Therefore, D, it's going to be, we conclude that the proportion of high school seniors who get drunk each month is not 29% when it really is 29%. So we rejected. We rejected the truth. We rejected the truth. We made a type 1 error. And now let's go to the second one. So a type 2 error in this case, we're saying the proportion is different than 25%. Therefore, a type 2 would be, we conclude that the proportion of high school seniors who get drunk each month is 29% when it really is not 29%. So to make a type 2 error, the null hypothesis is false, but you're going to accept it. Do not reject, fail to reject. So right here, you're saying that we conclude that the proportion of high school seniors who get drunk each month is 29%. Why 29? Why did I say 20? Oh, it's 20, 25. Oh my God, 29. I don't know. I just guess I think faster than I type or say it. So right here, we conclude that the proportion of high school seniors who get drunk each month is 29, when in reality it's not 29. In this case, we knew that the null hypothesis was false, but we accept it. Okay.